The adapter pattern is all about conforming an interface that you're given to the interface that you actually have. So let's imagine that we're doing a very simplified drawing application, and let's suppose that the only thing which our system knows how to do is how to draw pixels, individual points on the screen. So we may as well define a point with public fields x and y and some sort of constructor to initialize them, and let us suppose that the only piece of functionality which we actually have available to us is the functionality for drawing a point. So we have some sort of a draw point method which takes a point, and in our case we're just going to simulate the drawing of a point. I'm not going to take its x and y coordinates and try to set it on the screen, nothing like that. So this is the only interface that we have. Now let's suppose that somewhere in a different part of our application has built a vector drawing functionality. So they've essentially built all the pieces which are required for vector drawings, and we don't know how to do that. So let's suppose that they decided to make a line composed out of 2 points, start and end, once again with a constructor. And let's suppose that they extended this idea with the idea of graphic objects which are made up of collections of these lines. So you have a class called, let's say, vector object, which is a collection of lines, like so. And then they've gone ahead, and whenever they wanted to define a particular shape like a rectangle, they use this idea of a vector object, and they simply initialize it in the constructor. So in the constructor for the rectangle, for example, they would simply create the 4 lines and add them to the collection, which would look something like this. So in this case, if we have the rectangle taking the x and y coordinates as well as the width and the height, that would be how you initialize it. So you make the 4 lines with the appropriate points and you add them to the collection. Since we're a collection, we have the method called add. So this is how someone else has defined a rectangle as a vector object. Now let's suppose they decide to give us a bunch of these vector objects. So let's have private static read-only list of vector objects called vector objects. So they give us this list and they say, can you please draw it for us? And we may as well initialize it with a bunch of members. So you can see ReSharp are really stumbling here. New list of vector objects. There we go. So I'm going to make 2 of these vector objects. In fact, I'll have 2 vector rectangles. So we'll have a rectangle 1, 1 with width 10 by 10. It's actually a square. Let's have another square. So we'll have a new rectangle with, let's say, coordinates 3 and 3 and size 6 by 6. And by the way, probably want to call them vector rectangles, just to be explicit. So vector rectangles, there we go. Okay, so somebody comes up to us and they say, they give us this set of vector objects. They say, oh look, I have 2 vector objects, 2 vector rectangles for you to draw. And the point is, we can only draw individual pixels. So we can only draw individual points, and the question is, well, how can we then adapt one to another? Because we're given vector objects and we are kind of in the raster mindset. So this is where you build an adapter. You build a tool which actually converts a single line, because all the vector objects are made up of lines. You convert a line into a set of points, because a line can be represented as a set of points. So let's build an adapter. So we're going to make a line to point adapter, and this is going to be a collection of points, because that's what it returns. We take a point, we take a line rather, and we try to convert it in all the points which exist on this line. So here, in addition to all of the other things that we're going to be doing, I also want to keep the count of the number of invocations of the line to point conversion. So here I'll have private static int count, which is going to be 0 by default. And then in the constructor, what we do is we take a line, like so. First of all, let's write some information about this line. So I'm going to write line here, some info. First of all, I'll put in the number of invocations that we've made, number of conversions. So plus count will give me the values 1, 2, 3, and so on for the number of times we've called this. And then I'm going to say that we're generating points for line, and then I'll specify the line coordinates here. So we'll begin with line start x and line start y. Line start dot y. Let's put a comma in between them, and we'll put the ends in here. So this is going to be a line.end.x and line.end.y. There we go. So that's some diagnostic information. Probably got a spurious semicolon in here, and then we can actually compute the coordinates of all the different points. Now, once again, I'm not going to bore you with typing out all this code because it's actually quite boring, but here it is. So we essentially calculate the left, right, top, and bottom margins of the line. We calculate its x and y change, and it's either vertical or horizontal in our system. So depending on what it is, we once again call the add method, and we generate a bunch of points corresponding to this line, and we add them to ourselves because we are ourselves a collection of points. So having constructed this adapter, what we can now finally do is we can take these vector objects and we can actually render them using the draw point functionality that we have. So for each vector object in vector objects, what we're going to do is we're going to do another for each. So this here will be a for each var line in VO. Remember, each vector object is just a collection of lines. So for each of these, what we have to do is we have to make an adapter. So we say var adapter equals new line to point adapter. We feed the line to point adapter a line, and we get a bunch of points as a result. So a line to point adapter is a collection of points, and that means that we can do adapter dot for each. So I'm going to use more links for each here, and I'm going to call draw point on each of those points. Okay, so this is a very simple adaptation of a vector interface to what we have here, which is a raster interface. So once again, I can control F5 to execute, and we're going to see just a bunch of dots, but we're also going to see that diagnostic information that we added. Here we go. So as you can see, we have the lines being generated, or the points being generated for each of the lines, and you can see that for this line, for example, there are 10, I believe, 10 or 11 points generated, and they're shown here. We could output them with their actual coordinates, but I'm just putting dots out here so that you can see that something is in fact being converted. So as you can see, we've generated a total number of 8 different point sets for a line. And this is okay until you refactor this and move it into a separate method. Let's actually select this and extract a method. We're going to call a method draw. And then let's take a look at what happens if you call draw twice. If we execute this, you can see that we've now generated the lines or the point sets for the line 16 times. And that was completely unnecessary. So unfortunately, the side effect of using the adapter is that it generates a lot of temporary information, and in the next clip we're actually going to see how to reduce this amount of temporary information by using caching.